Welcome to the TunnelVision POC video. Danny Krantz and Lizzie Marathi from Leviathan Security Group were the research team that found this issue. We will be going over two lab setups. The rogue admin setup assumes the attacker is the authoritative DHCP server and uses a standard DHCP service. The second setup uses our tool, Arcane Trickster, to assume the role of authoritative DHCP server. Links to the blog and GitHub are in the description below. We'll start with the rogue admin configuration. In this network, the attacker already controls the DHCP server and can manipulate leases at will. They use option 121 to install malicious routes into the victim's routing table, causing them to leak traffic from the VPN. To show the ubiquity of this technique, the victim will be running WireGuard as their VPN. On the left is the DHCP server, and on the right is the target VPN user. On the DHCP server, we first start the ISC DHCP service. This is the non-malicious configuration we use to create a baseline. On the victim, we have several terminals showing how the lease affects network configurations and traffic. Let's start by dumping ICMP traffic from the WireGuard interface. We can see that the DHCP server has assigned the victim the IP 10.10.10.146. Let's generate a bit of ICMP traffic by pinging 8888, also known as Google DNS. This will be our canary for traffic leakage. The terminal shown will dump ICMP traffic going over the victim's physical interface. If we see anything here, then the attacker is also able to read it. As you can see, the traffic is not going over the physical interface on the right, but the WireGuard interface on the left. Back to the DHCP server. Let's push the malicious configuration. Specifically, we're adding a route to Google DNS for the physical interface. Here's the new DHCP configuration containing the RFC 3442 option. We're going to have to wait for the victim to renew their DHCP lease before the route will be installed. The physical interface is now leaking the traffic to Google DNS in the right console. Taking a look at the victim's routing table, we can see that the third entry is sending traffic for Google DNS to the physical interface, ENP0S3. We're going to switch back to the non-malicious configuration to show that the attacker can change these parameters at will during the VPN session. Once the route entry for Google DNS disappears from the top left console, we'll see ICMP traffic return to the WireGuard interface. Let's pause the victim and move over to the advanced lab setup. Our tool, Arcane Trickster, will first starve the DHCP server by collecting all of the available leases, and then offer the client a lease it generates. We plan to implement DHCP lease hijacking as well before release. In this setup, the previous DHCP server is no longer considered compromised. It will act as the authoritative server for the network. The attacker is now an adjacent machine on the local network and will transition to being the de facto DHCP server. Once it solidifies its control, it will offer a lease to the victim with the option 121 route. In the top console, we'll start up our rogue DHCP server. The output is showing the leases it's currently collecting. Arcane will automatically renew those leases to keep them indefinitely. We'll know it's done once we stop seeing new leases being logged. Then we'll unpause the VM to simulate a new device joining the network. After 60 seconds, the victim's old lease will expire, and it will need to obtain a new one. It will have no choice but to accept Arcane's lease. Note that Arcane does not need to race the server because of the renewal mechanism. The leases look settled, so let's go ahead and unpause the victim now. The old lease is still being used. Let's wait for it to expire. Meanwhile, we're just going to clean up these terminals to make it easier to tell when the leak happens. There it goes. The physical interface just lost its lease and is trying to obtain a new one. The victim obtained a new IP, 10.10.10.168. Let's look at what the attacker sees. The victim's traffic is now decloaked and being routed through the attacker directly. The attacker can read, drop, or modify the leaked traffic, and the victim maintains their connection to both the VPN and the internet. We can see the Google DNS route was installed and is redirecting the ICMP traffic outside of the tunnel. Thanks for watching, and again, there is more technical information on our blog post about this technique, including a nuanced discussion of when this is considered a vulnerability. Our research tool, Arcane Trickster, will be released once we've finished coding the lease hijacking module. If you liked our research, like the video below. If you want to make sure you know when we release new research and information, subscribe to the channel and turn on notifications so you don't miss any future posts. To learn more about the work we do, visit us on our website at leviathansecurity.com. To find up-to-date information about TunnelVision, head over to tunnelvisionbug.com.